Greetings, Houdini Python students. This is Chris Rhoda. The topic for this lesson is the Who.Parm class. Now, this class manipulates the behavior of all the Houdini parameters. And while not as complex as the Who.Node class, the Who.Parm class is still quite extensive. Please look over the Houdini docs for the Who.Parm class information. It's quite extensive. Now, we're going to start off by creating a variable for the values ty parameter. And we're going to pull down my Houdini Python shell and say ty equals, and I'm going to drag the parm over to this. Now notice that when we drop the parameter onto the new variable, instead of a parm, we got a parm tuple. Now, parameters quite often work in sequences, and we can simply access the individual parms ty by accessing the parm tuple index, which in this case is 1 for ty. And I'm going to add the value of 1, and we have the value. Now, the first method we're going to look at is the venerable old name method. So ty.name is the name of the particular parameter. However, the path ty.path gives the full path of the parameter being worked with. The eval is quite a extensive method where there's a plethora of opportunities, and however, the simplest is simply the eval, which evaluates the channel at the current frame. So I'm going to say ty.eval, and I get the value. If I change the frame for this, I'm going to get something probably a little bit different for 155. Okay, now it gives the value at 155. If we wanted to check the value at a particular frame, let's say for 216, then we use the method eval at frame and say ty.eval at frame. And we say 216, and we get the new value for that ty value at frame 216 is 5.89. Now, I highly encourage the user to experiment with all the different variations of this method because it's quite powerful. The next method, tuple, returns the who.parm tuple the current parm is contained with. Now, quite often these parameters travel in groups, and quite often groups of 3. So I'm going to say t equals ty.tuple, and that's going to return basically the whole translation tuple. Now, although it is a data structure, the value, or the parm tuple, behaves just like a simplest list of the form. So we can do a length of the value of t, and we can do a for operation on it so that we can get the list of what's all contained in the name, or in the parm tuple name. Okay. All right, and this shows that we get tx, ty, and tz. If we wanted to delete all of the keyframes of a particular parameter, then we use the delete all keyframes method, which deletes all the keyframes of the current channel. And we'll create a new variable, and it's called ry, which just happens to be animated with keyframes instead of an expression. So, all right, now the index for ry, it just happens to be, whoops, not 0, but 1. Otherwise, that would have been x. Now, I'm going to go ahead and delete all of the keyframes for ry. So ry.delete all keyframes. All right, so you notice that this little box turned from green to white, and that means that the box is no longer being rotated in the ry dimension. It's still animated in rx and rz, but not ry. Now, this sets us up for the set method, which is going to be doing next. And things can get a little bit confusing without an understanding how Houdini Python handles keyframe animation, which we'll cover in the next lesson. And so set actually sets the parameter value at the current frame. So I'm going to say ry.set 45, and this is going to set the rotational y value of this channel at 45 degrees, and it's going to stay at 45 degrees as we animate it. If we wanted to put an expression in there instead of the constant value, we would use set expression, ry set expression, and the input for that is a string. So I'm going to put a very simple little string, 2 times frame, and end quotes. All right, so this is now going to be executed with a certain, is going to be rotating with the y in correspondence with the actual frame value. Now, if we wanted to get the value of what that expression actually is, we would say ry dot expression, and it will return the expression driving that particular parameter. Now, let's return back to what was keyframes. If we wanted to grab all of the keyframes of one of these animated channels, let's say for Rx, so I say Rx equals, and I'm going to grab the Parm tuple here, and the index of the Rx is 0, so all right, and I'm going to grab all the keyframes, and the keyframes is the method name, so Rx, so I'm going to say keys equals Rx keyframes. So that returns a Parm tuple containing all of the keys in there. I know we haven't gone over the Python animation yet. This will give you a preview of what the keyframe data structure actually is going to look like. I'm going to expand this out a little bit. I'm going to do a for key in keys. I'm going to print out all of the keyframe information. Okay, you see here it had 4 keyframes on it, and this is the basic data structure of the keyframe. Now, if we do the same thing for ry, say for key in ry dot keyframes, and if we print the key for that, ry, oops, I didn't get ry in there, my bad. All right, you see the big difference between the ry and the rx is that rx is driven by animation functions, which in this case is Bezier, and ry is driven by an expression, which is 2 times keyframe. So this is a quick introduction of the keyframe data set. And the last method that we're going to go over is as code. And I'm going to say ry as code. And as expected, we get a cacophony of Python commands. And this is always more readable when it's written to an external file. And after it is written, however, it can be imported as a module back into Houdini, and you can set your parameters by calling this module's methods. So as a recourse, in this session, we covered the basic and common uses of the Who.Parm class with a brief introduction of the future Houdini Python animation section. And as always, feel free to use the Houdini docs in order to get the full access and usage of this particular class. Now, in the next session, we'll cover the Who.Object Node class. I'll see you in the next lesson.